Text-to-image models are getting smaller, faster, and surprisingly powerful. Hi everyone, welcome back to the channel. In today's video, I'm testing FLUX to KLEIN, specifically the 9B digital model and the 4B base model. And I'll be comparing the results from both these models with the Z Image Turbo using exactly the same prompts. And all of this is running locally on my PC, so no cloud, no APIs. So you'll see what kind of results you can realistically expect on a consumer-grade hardware with a video RAM of 16 gigabytes. So what is FLUX to KLEIN? FLUX to KLEIN is designed to be a compact but high-quality text-to-image model targeting strong prompt understanding, good visual coherence, and efficient performance on GPUs with limited video RAM. Today, we'll look at two variants, FLUX to KLEIN 9B Distill, which is a larger, more refined model with better reasoning, and FLUX to KLEIN 4B base model, which is smaller, faster, and more accessible, although with some compromise on quality as compared to the 9B model. The big question is how much quality do you actually lose when you go smaller from 9B to 4B? So I'm running a consumer-grade GPU with a RAM of 16 gigabytes. I'm running everything locally, so let's get to it. If you go to the Comfy UI website, you'll find this page about FLUX to KLEIN, and this page lists information about both the FLUX 4B and the FLUX 9B. If you scroll down a little, you'll find the workflows for FLUX 4B as well as the models that you can download. And they've also provided workflows for FLUX to KLEIN 9B as well as the models to download. So if you click on the workflow that you want to download, you can right click and save as. But here what you will see, this will be saving your file as a TXT file, which you do not want. So what you need to do is right click on any of the workflow. Let's, for the sake of this video, click on this 4B text to image workflow and open in new tab. If you go to the new tab, you'll find this code. You need to right click and click on save as. Now you can point this to the folder that you want to save it to. What I'll do, I'll browse to my Comfy UI folder, and there I have created a folder named workflows. Now for the sake of organization, I organize all the workflows within different folders. So I've created a folder called FLUX to KLEIN where I will be saving this workflow file. So I've already done this, so I'm not going to do it again. I'll click cancel. Now I'll go back to page, and what I'll do, I'll just click on any of the models that I want to download. So what you can see, they have provided for the 4B model a base model as well as a distilled model. Now the base model is the original model that is trained on the data that they have used, and the distilled version is a kind of a refined version of the base model, and it is about 80 to 90% similar in quality of text to image as compared to the base model. But the advantage of creating a distilled model is that it runs faster as compared to the base model. So depending on the amount of video RAM that you have, you can choose either of those. I'll choose the base model. So if I click on this, this will start the download. I'll cancel it because I already have downloaded it. What you can do, you can look at this folder structure that they have provided along with guidance for which files to be placed where. So if you download the base 4B model for FLUX to KLEIN, you will need to put it in the folder diffusion models. So let's go to my Comfy UI folder. If I go inside the Comfy UI, I can see there's a folder named models. If I go inside, there's a folder called diffusion models, and this is where you can save your models. What I do for the sake of organization, I create different folders, so it's easier then for me to find where the download model resides. So here I've created a folder called FLUX 2, and here you can see I have already downloaded the FLUX to KLEIN 4B, and this is a base model. Now if you go back, what you need to do as a next step is you need to download a text encoder. So in this case, it is Qwen3 4B safe tensors. Now, if you click on it, this will again start downloading. What you need to do after the download finishes, you need to put this inside your folder, Comfy UI folder, you need to go to models and then go inside the text encoders. Now you can pretty much copy your files, your model files here, but what I do, I create separate folder. I've created here as FLUX2, and here I have downloaded the Qwen34B FP4 FLUX2 file. Now for the last file, you need to download a VAE file, and similarly, when it is done downloading, you need to copy it inside the VAE folder. So again, if you go back inside the model folder, you can see there's a folder named VAE, and here you can paste your FLUX2 VAE file. So with that out of the way, what you need to do now is you need to fire up the Comfy UI. So inside your Comfy UI folder, you can see there are 3 files. So if you have an NVIDIA GPU, you can click on this and this will start loading the Comfy UI. And if you have an SSD, the loading of the models is pretty much faster, and the startup time for the Comfy UI is very much minimized. Now Comfy UI has started. What you can do, the workflow that you downloaded, you can go inside the location where you have downloaded the workflow, and then what you can do is drag and drop the workflow file inside the Comfy UI, and this will load all the files that are already there. Now, this may give you some warnings regarding availability of certain files and folders. What you can do is pretty much close it for now. And here, this will give you a markdown note where it lists the locations for the files that you've just downloaded. And it also shows you where you should be saving all the files. Apart from that, we have different nodes which help us run the models that we have downloaded as part of FLUX2 KLEIN. So what you can do, if you click on this edit node, this will take you inside and this will give you the details of the overall structure. So this is basically a clef node. And what you can do is go back to the main UI, and here you can see you can set the resolution. So here we have the resolution set already as 1024 by 1024. You can leave pretty much the noise seat as it is. Now in the unit name, this is where you choose FLUX2 KLEIN model that you have downloaded. So I have saved it inside my diffusion models, and what I can do, I can choose FLUX2 KLEIN 4B safe tensors. And just underneath it, I need to choose my text encoder, which is Qwen34B safe tensor. And then we also need to choose the FLUX2 VAE safe tensors. If you go again inside the edit, this will show you the number of steps that will be used to generate the image to enter. So the steps for the base model as well as for the base model are 20. So what you can do is, again, go back and you can take a prompt and then use it to generate the image. So let's use this prompt. The prompt reads as: a beautiful young woman standing barefoot on a quiet sandy beach during golden hour at sunset. Warm orange sunlight illuminates her face from the side, creating soft highlights on her skin and gentle shadows. She has natural makeup, expressive eyes, and realistic skin texture and visible pores. Long hair flows slightly in the ocean breeze. She's wearing a light summer dress that moves naturally with the wind. Shallow depth of field, cinematic portrait photography, 85mm lens, and photorealistic lighting. So let's click on run. Now, the first time you run it, it takes a little longer. So in my case, it took about 78 seconds, which is just about more than a minute. But if you run it the second time, trust me, it becomes even faster. Now let's look at the result. You can see it has generated an image. The lighting and everything else seems pretty good, but the FLUX2 KLEIN model is not very good at generating human anatomy, especially the 4B model. You can see there's problem with the height. Her hands seem a little strange, and her eyes or makeup seems a bit off. So what I've done, I have tested the results from the 4B model, the 9B model, and I've also generated images in Z-Image Turbo model using the same prompts. And I'm going to show you how it compares. Now you can see I have used the same prompt for all the 3 models: the FLUX2 9B distilled model, FLUX2 4B base model, and the Z-Image Turbo. The prompt was a small matte red cube carefully balanced on top of a large transparent glass. There is a subtle shadow underneath the ball. there is a shallow depth of field, and it does look photorealistic. If you compare the image from 9B versus the 4B model, you can see the reflections and the refractions from the 9B model seem rather more accurate compared to the 4B model. However, in terms of understanding the prompt, such as small red cube carefully balanced on top of large transparent glass, both have nailed it. If you look at the image from the Z image turbo, this seems a bit off. The cube is as big as the glass sphere itself. So in this case, I would say Flux 2 9B and Flux 2 4B both have done a good job. Now, in this prompt, what I've done, I've given it a prompt of a tall woman walking on a rainy city sidewalk wearing a bright yellow-red raincoat. So you see there are clearly some problems with the anatomy that the Flux 2 4B has generated, whereas the 9B digital model seems to be doing pretty good as far as the face is concerned. However, you can see some problems with the hand anatomy, whereas the problems are more pronounced with the 4B model. But on the other hand, you can see the Z image turbo, as far as the anatomy goes, has done a pretty good job. Also, when it comes to prompt understanding, 4B has trouble figuring out the sidewalk, because in this case, it seems like the lady is walking in the center of the road and there are cars driving on both sides of the road. Whereas the Z image turbo and the 9B digital model seem to be performing better in terms of prompt understanding. So in this case, I would say the image generated by 9B digital model seems more vibrant. Now in this prompt, what I've done, I've asked it to create 7 tall candles, which you can see 4B has trouble when it comes to positioning the candles, although the circle seems to be there when it comes to positioning the candles. If you look at the result produced by the 9B digital model, it has done a good job. If you compare it with the Z image turbo, this seems like a bit bland, lacking the contrast and a bit of detail on the floor, and wax dripping is not there on all the candles, although you can see it's visible on the floor. So in this case, I think the clear winner is Flux 2 9B. Now, testing the photorealism, I gave a prompt which says a candid street photograph of a middle-aged man crossing a rain-soaked city street at night. Here again, you can see the image generated by 4B has done almost good when it comes to anatomy, but the man is walking in the middle of the road rather than crossing the street. Whereas you can see the image generated by Z image turbo and the 9B digital model clearly understand what crossing a street means. Again, you can see there's a clear difference in terms of contrast, where the image generated by the 9B digital model seems to have more contrast compared to the image generated by the Z image turbo. Now in this image, I asked it to generate a high-speed photograph of a seagull taking off from water at dawn. You can see the image generated by 4B has some problems with the anatomy of the legs of the bird, whereas the image generated by Z image turbo seems to be holding well. But if you can see, there are no droplets frozen in the midair except for few that are underneath the bird. Details of the feathers is quite pronounced in both the Flux 2 models, both the 4B and the 9B. But I would say clear winner in this case is Flux 2 9B. Now, in this image, I gave it a prompt of a macro close-up photo of a stainless steel luxury watch on a human wrist. You can see the image generated by 4B base model has clearly problem with the anatomy, and the image generated by Z image turbo seems to be overly focused on the metal. In the image generated by the Flux 2 9B digital model, everything seems right in terms of anatomy, as well as focusing on the stainless steel luxury watch on a human wrist. So in this case, the clear winner is Flux 2 9B. Now, in this case, I wanted to generate a hyper-realistic close-up portrait of an elderly woman with deep wrinkles, visible pores, and subtle age spots. Image generated by 9B digital model has lots of details and a reasonable contrast, whereas the image generated by 4B base model also seemed to have quite a few details, but a little less contrast, whereas image generated by Z image turbo seems to lack the detail. So I would say the details in terms of a hyper-realistic close-up portrait of an elderly woman seem to be holding well in all 3 images, but the details generated by the FLUX2 9B as well as 4B are higher. Now, in order to test the understanding of human anatomy, you can see FLUX2 clearly has some problems. You can see in the image generated by 9B, the prompt is about a person holding a ceramic coffee mug with one hand. Everything else seems to be holding well, but the handle of the mug is crossing between the ring and little finger, which is not very realistic. And the image generated by FLUX2 4B base model clearly seems to have problem where there's handle on both sides and there are two hands holding the cup, whereas the person is missing in the background. Image generated by ZImage Turbo seems to have a good prompt understanding when it comes to human anatomy. Now, in this prompt that I gave to all the three models, I asked to create an image with a full body photograph of a person walking down the concrete stairs, captured mid-step with 1 foot lifted. You can see the image generated by 4B clearly seems to have problems with the human anatomy. 9B digital model has done a reasonably good job, but it's not clear as to why the foot that is in the air has motion blur, and I think the proportions seem a bit off. The image generated by ZImage Turbo seems to be correct in terms of human anatomy, but the person isn't actually walking down. Now, I gave this prompt of a professional ballerina balancing on her left foot in dramatic pose, and you can see there is a clear problem with 4B base model with understanding of human anatomy, whereas the image generated by 9B digital model seems to be better compared to the 4B base model. However, the anatomy seems to be exaggerated, and I think there is something off with this left foot of the ballerina. Whereas the image generated by ZImage Turbo seems to be doing pretty well. Now, when it comes to generating the environmental art, I gave it a prompt which says, a lone female astronaut standing on the dusty red surface of Mars at sunset. You can see the image generated by ZImage Turbo seems to be photorealistic compared to the images generated by both the 4B and 9B model, which seem like a fantasy. Perhaps adding a term in the prompt such as photorealistic could change the results. Go ahead and test it and let me know what results you get in the comments section below. Now again, for our final image, I gave it a prompt of a single candle placed on a wooden table inside a dark room. If you look at the image generated by the 9B model, it seems to be clearly doing better when it comes to the image generated by the 4B model or even the ZImage Turbo. The reflections on the wall seem a bit off in the image generated by ZImage Turbo, whereas photorealism seems a bit odd in the 4B base model. It took about 78 seconds when I generated the first image. Now, when generating the second image, you can see the time difference. The model runs really fast, and there you can see it only took about 21 seconds on a system with 16 gigabytes of video RAM. So this is about the FLUX to KLEIN text-to-image workflow on both the 9B and the 4B models. Now, the AI community is very active, and it doesn't take long for the community to create quantized models, that is GGUF files, which you can run on your PC with low video RAM. Similarly, an account named Unsloth has created quantized versions of the FLUX to KLEIN 9B as well as the 4B. So if you look at the 9B, the smallest model is about just under 4 GB. So depending on the amount of video RAM that you have, you can use either the 9B GGUF model, or you can also use 4B, which can be as low as under 2 GB of video RAM. So depending on which one you prefer, you can choose and run that model. Now what you need to do, you need to click on the download button, and then you need to save it in your Comfy UI folder, models folder, and then inside the models, you need to go into the UNet folders. So in this, I have created, as usual, different folders for different models. So with the folder name FLUX2, I have downloaded and saved the models. Now inside the Comfy UI, what you need to do is you need to hold Control on your keyboard and drag to select these two nodes, and then press Control V to bypass these nodes, and then again come down and holding Control drag across, and again press Control B to unbypass the nodes. So this is a way to make sure the only nodes that you want to run are active. So what you need to do on this node, text to image, you need to click on edit, and when you go inside, what you need to do is double click and type GGUF. Now here you will find this GGUF loader node. Just click on it, and I'll just make it a little larger. And inside this will detect the models that you have downloaded inside your GGUF folder. So here I will type FLUX2, and there you can see I have downloaded both the QB Q2 4B Q2 quantized model and the 9B Q2 quantized model. So I'll just select 4B, and now you can see this diffusion model node is connected with this model on CFG guider. So what you can do is simply drag and connect it here. So this will detach this load diffusion model. So you can delete this node as well, or you can leave it as it is. I'll just leave it there. And apart from that, I'll now just go back, and here I will leave the selection as it was for the FLUX2 KLEIN model, as well as for the text encoder. I won't touch them. I will just leave them there. So I'll just paste a prompt, and then I'll just run. And you can see this is super fast, and this creates an image. Now it has its own issues because this is a quantized model, so its prompt understanding cannot be compared, but still this will help you generate images at a very low video RAM. So that's it for this video. I hope you like this video. Let me know your thoughts in the comment section below. Like and share this video and subscribe to my channel. Until next video, bye-bye.